Hello. Let's answer the fifth question for the Math Wiz Quiz 4, which is a online quiz bee simulation for a collegiate math contest in the Philippines. For this question, we are given a list of five positive integers where the mean and mode are 5. We are asked to find the largest possible population variance. This question was asked during the 2020 edition of the UP Math Club Math Wizard. And for this one, before we actually look at the solution, let's look at first or review first the definitions of statistics terms mean, mode, and variance. Mean is basically the average of the elements of the list. So basically, we just add all the terms and divide by the number of elements. And then the mode is the most frequent element in the list. When we have more than one element, or for example, 1, 1, 2, 2, 5, both 1 and 2 occurs twice. So the mode for this set are both 1 and 2. So we call this set bimodal. If we have 3 having the same frequency, we call them trimodal and so on. And then lastly, we look at the variance. The variance is basically the distance or the sum of the distances from the mean. So we subtract each element of the set from the mean, and then we square them, and then divide the sum by the number of elements. Okay? Now for the given problem, we are given that the mean is 5 and the mode is 5, which means that in the set, we have something like blank, blank, 5, 5, and then blank, where these three are distinct. Otherwise, we'll have a mode that is not necessarily just 5. We will make use of the fact that the mean is 5. Since we know that mean is equal to the sum divided by the number of elements, which in this case is 5, if we focus on this one, multiply both sides by 5, we get that the sum of the elements is 5 times 5 or 25. Okay? Now to maximize the variance, what we do is we just find 3 elements that are as scattered as possible and then find the corresponding variance. So for example, let's say the first element is 1 and then 2, 5, 5. Since the sum is 25, the third element must be, or the fifth element must be 25 minus 1 minus 2 minus 5 minus 5, which is equal to 12. So the third element or the fifth element here is 12. The mean is 5. So xi minus mu in this case is 1 minus 5, that's negative 4. This is negative 3. This is 0, 0, and then this is positive 7. We square them. So if we square them, we get negative 4 squared, negative 3 squared, and so on. So this is 16, this is 9, this is 0, this is 0, this is 49. And finally, we add them up. 16 plus 9 is 25, plus 49 is 74. Therefore, the sum of the distances from the mean is equal to 74, and therefore the variance for this one is 74 over 5. Now we can check other possible combinations of elements. Let's say we instead pick 1, 3, 5, 5, and then the last one would be 11. Then again, get the distances from the mean. This is 4 squared, 2 squared. Let's just add them up. 0 squared, 0 squared, plus 6 squared. This is 16 plus 4 plus 36 gives us 56. Therefore, the variance for this case is 56 over 5. Clearly, 74 over 5 is larger than 56 over 5. So this is a good candidate. Now we just repeat this process. Actually, we have to iterate through all combinations of this thing here, this list. But you see that as you stray away from 1, 2, and 12, you'll see that the variance actually decreases from 74/5. So the answer for this question is 74/5. Or if you want decimal, this is also equal to 14.8. And that's our final answer. I hope you learned something from this video. If you have any questions, comments, clarifications, violent reactions, just let me know in the comments. Thank you. Bye-bye.